Today's video will demonstrate how to implement the factory design pattern for the game of chess. Hello, I'm James Helfrich. The design patterns are useful in a wide variety of contexts to decrease code complexity as well as increase adaptability. This video will demonstrate one such example by applying the factory design pattern to the game of chess. The factory design pattern is a function or method used to instantiate the requested variation of an object. Now we start with the client who wants to have a new object, and he's going to send an object identifier. Usually this is an enumeration or an ID or something to the factory. And the factory is usually a single function or method, which will then return the new object, or more specifically, a pointer to the object. Factories facilitate the creation of objects that are members of a polymorphic set. In other words, any type of object that a factory returns must have the same common base class. So let's take a look at how this works with chess. So I'm going to have a board, which is going to have a collection of pieces. How many? Well, 64. Now, since the board is going to create and destroy the pieces, this is by composition, which is a filled diamond end cap. Now, the piece will also have a position on the board, and it'll have exactly one of those. Now note that a king is one type of piece, and a queen is a type of piece, and so is a rook and a bishop and a knight and a pawn and a space. Now clearly, when I create a new board, I'm going to have to create a collection of different pieces, in fact 64 of them. So it looks like the factory design pattern might be a good use of this. We'll begin by taking a look at how this used to be. We're going to have a bunch of spaces, a bunch of pawns, and a bunch of rooks and knights and bishops. Now observe that since there's going to be 32 different spaces, I can create a for loop to easily create those, not a problem. And in fact, there's a lot of similarity in how I create pawns. I could do 8 in a batch, not a problem. However, the rook, the knight, the bishop, the king, and the queen all have to be individually created. So that's going to be a little bit of repetitive code. Let's see if we can find a better way than this. Let's take a look at our new design. In our board class, we're going to have an 8x8 array of pieces, okay? And in my piece class, I'm going to have a piece factory that's going to take a piece type and a column and a row and whether I'm white or black. So what is a piece type? A piece type is just an enumeration of different types of pieces. This is my object identifier. Okay, so now I'm going to go into my factory for my piece, and I'm going to say, hey, switch on piece type. If it's a space, create a new space. If it's a king, create a new king, and so on. And this is the essence of the factory method. Now, how am I going to implement it? When I go into my board, my reset is going to have is going to call factory for space and pawn and rook and knight and king and queen. Now, this doesn't really help a lot. This is not really different from just calling new. So I'm not really seeing an advantage right now. So maybe we can do better. Okay, now that I'm finished here, I have a data-driven design. I could easily verify by looking at my 8x8 array of piece types that my board is set up correctly. And now I can have just a single double for loop to run through the whole thing. Actually, got to make sure I set my row and column correctly. Okay, let's make sure this works by verifying my unit tests. Perfect, everything passed. As you can see, the factory can greatly simplify the code as well as make it easier to make changes. You can learn more about the factory in the factory section of the object creation chapter of the software design textbook.